So I think step one would be to just take apart the toolhead, take a look at the hot end, especially the Bowden tube, just double checking that everything is in order there, and then just trying another print. I kind of have bad news. I ordered fans. The fans arrived. I unpacked the fans and I put them here on the table. Unfortunately, I have no clue where those fans went. So I hope I just misplaced them somewhere. So basically we have to stick with these super high quality AliExpress fans for today. So any cooling related issues we won't be able to fix. But yeah, my hope is that mostly it will be just extrusion issues. So I will just focus on that, and then let's see where that leaves us. Cool. Yeah, that being said, let's just start and take it apart. Oh, I also, I didn't do anything between the streams actually. The only thing I did, oh yeah, and we're printing a spool holder, a very minimal spool holder at the moment. I totally forgot to print that. The only thing I added is like little rubber feet on the bottom. So this is no longer sliding around. Like you see, if I wiggle on the printer, entire table, including camera wiggles. So that should just be like a bit more stable. And yeah, I think let's just start with the toolhead. Let's just see where that leaves us. Let me quickly, it's actually running at the moment. Let me just quickly shut down the Pi. Let me shut down the Pi. Okay, that looks good. Then let's cut the power. Last time we did a little bit awkwardly with the cable, right? Like we kind of attached on a cable. Otherwise, I have to cut the. Let's actually do that. Let's just disassemble that properly. Then we have like space to work. So let's start with this hidden screw in the back. And 2 screws in the front. Then we can lift it off. Exactly. Now, it's a bit awkward. Like the strain relief is quite good in the sense that like it really prevents the cable from moving because like it's on top here. But yeah, you can't remove the cable at all with the strain relief in place. So you always have to at least loosen the screws left and right. And then we can cut the cable tie. And then it kind of like comes apart. But yeah, you really have to like disassemble the electronics port to remove this cable here, which is a bit of a shame. Okay, let me park that. Here we go. So let's do like some post-mortem and actually like attach this again, because I hope that we don't have to disassemble that. So my suspicion is that it's really like a Hotend related issue, because last time we also had a clock, if I remember correctly. Let me see. Let's actually try to take out the entire thing first. Which is a bit awkward with the rest of filament there. Hi there, Sven. Okay, that's a bit. Maybe we should have removed it before taking it apart. But the fact that this doesn't come out might already show part of the problem. Let me maybe try. Usually you should do that like hot. So maybe it's also, yeah. Maybe we should like connect that, turn it on, and remove the filament quickly, because this will make it much easier for us to work on the entire thing. last time we killed the fan while doing that because like I think the problem was that there was like no airflow whatsoever over the fan. So let's just learn from that and kind of like prop that up a bit. And then I would just like turn the printer around. No, now we tightened that again. Let's connect that. Okay, and then we can turn it on. So let's give this a second to boot up. The Pi Zero is not the fastest horse in the race. Yeah, and then I think like the one, like let's remove the filament. Then the interesting part would be maybe first to remove the Bowden tube and have a look if we can remove that. If not, potentially there's some filament blobbed up in the front of the hotend, which already might explain the issues we have. And afterwards we can just heat it up and then like undo the nozzle and take a look at that. Let's see. Okay, so we are booted up. So let me just heat it up to 200 degrees. The fan is running. Sure that this has like a little bit of airflow. I have another one of the 12-volt fans. So if we kill this one as well. But yeah, like I've actually like I ordered the fans from 3DO in Denmark and it arrived and I have no clue where I put them. I literally have no clue where they ended up. I had quite a big mess here on the table. So I really fear because I had like a lot of like packaging material that like I accidentally grabbed packaging material together with the fans and just trashed everything. At which point the trash was collected this morning, so it's too late. But tomorrow I will just like look around again and hopefully find them. Otherwise, order another set, which would kind of suck. Okay, let's see. Yeah, it's also like it's curling to the sides. That's never like a good sign. At least the filament is out. Let's see if we can. And now we can also pull the Bowden. This should be easier. Try to. Yeah. So there's definitely some filament still in the Bowden. So I think the problem is that like the Bowden tube wasn't quite pushed to the front, and then we had like a blob there. Let's just take off the hot end, the nozzle, to be sure that there's nothing left. Oops. I kind of forgot to have a nut ready for the hot end. We also never did like a hot tighten, so potentially was also part of the problem. But then it would have leaked like on the nozzle, I guess. But there's definitely like you can see there's like filament in the windings or like in the thread of the. Like you can see it here. Maybe if there's like a little bit of like pink stuff in the thread, so there was definitely something leaking. I see stuff. Sure if you can see stuff too. No, it's like impossible to see. Like there's something rough in the Just try to not burn my fingers. Yeah, there's definitely like filament, bits of filament kind of in there. I can wind the heat break down one turn. You mean the screws? If I can like tighten the screws here? Or you mean like remove the screws and turn the block basically? I mean, right now it's pretty hot, so let me maybe first turn it off. Yep. Why can I not reach the pi? Okay, pi has LED. Okay, it doesn't get a proper shutdown. Okay, let that maybe cool down for a second. But you also see here on top, like, I'm sorry, it's like really hard to show with the camera. But there you can see some pink stuff. So there's definitely like filaments flying around in here. And we should definitely clean this up. I think that's part of the problem. To be honest, let's waste no time. Let's just take the block and the heat break from this one. This one is a 12-volt unit. I still have a project planned up, or yeah, project planned where we built like test bed for printers, but like a software test bed. And the hardware I was looking at was like at 12 volt, because the steppers I use will be 12 volt. So I have two of these actually, because like there it doesn't really matter how good the quality is. So let's just use this one, because then I assume it's properly assembled. I mean, Steve, I think you were kind of like on the right track, because if you look at this one, there's a gap between the nozzle and the heat break, right? So I assume this was not the case for this one here. So I think the heat break is not quite like far enough down. So there's a gap in the block between the nozzle and the heat break where the filament maybe leaks out. Because this one definitely is tightened against the heat break now. So let's just use this one. Let's not waste any time. And just remove the heater core, because this one is A, crimped, and B, it's 24 volt. Oh, and I treated myself to like a nice set of hex drivers. I was craving good drivers for some time, and this week I decided to treat myself to one. It's my favorite brand of screwdrivers, Viha. It's from my hometown. Let's go down. So let's get rid of the old one. Oh, we have to remove the and then let's also double check the bone tube, that the bone tube is at the correct length. Cool. Yeah, that was basically it, right? So we need to transfer this screw here. This needs to stay here. Oh, I also now see that we didn't tighten this screw here in the front. This one. I'm not quite sure if this has any impact. This little. But yeah, looking at that, I think you're definitely right, Steve. The heat break is not far enough in. Like also when you compare it to the new one, oh, it's almost at the same height actually. Tad lower. But yeah, let's not waste any time there. Okay, then always a bit fiddly with thermostats. I want to make sure that both sides of the cable are a little bit like held down by the screw. And then we also have to insert the heater cartridge. Okay, I think that's kind of okay. Let's not forget the bone tube. So the bone tube, this side is quite nice. Like it's very, just to have like a straight edge to compare it to. This side looks very good. Like it's quite in the right angle. This one is really jagged, but it's fine. We only need one good side. Let's put a good side in. Let's be sure to not pinch any of those cables. Okay. Stops the heat break from turning when you take the nozzle out the grub screw. Yeah, usually yes, but here we also have two screws left and right. So even without the grub screw, I think it really just holds it in place, to be honest. Because even without that grub screw, like you cannot turn that. That's completely fixed. What you can do maybe is like push it down. Not sure. But yeah, even without the grub screw, like this is really tight. That was like one of the things like with these like cheap Ender heat breaks that like they were pretty bad at isolating the hot end because like they had like 3 contact points. And the better ones, which that was like quite a common upgrade, the Micro Swiss. There you didn't have the 2 screws left and right. You only had that grub screw in the center. That basically holds it in place. Yeah, and this one is, by the way, is the defective one from the switch wire, where basically the grub screw down here is stripped. No, even with the new driver. This one is stripped out, so yeah, I cannot really remove the heater cartridge, and we also had the problem that this one was leaking, so I have it still in the hope that I can fix it, but most likely not worth the effort. Here you can see again, like there's definitely like PLA in the threads. Okay, then this one we will use for our dummy, where like it doesn't even have to like handle any filament, it just needs to heat up. Okay. Cool. Then I think this should be all fixed up. Put the sock back on. And then I would say, like, let's just try to print something again and see if the extrusion now looks better. MGN 15 rail or 8mm linear rods for X and Y axis. Linear rail. I do not have any qualified opinion on that. 8mm might be too small because you mentioned you try to build like a really large printer, right? So the larger or like the longer the axis, the stiffer it needs to be. So 8mm rod for like a 300mm machine might be too little. So I would go for MGN 15. Maybe MGN 12 would be enough, depending on what you mount the linear rail to. Maybe check out the Retraction V4, what they use, because they also have like really large printers, like the 350. And they only have, if I remember correctly, the linear rail mounted on both sides, but they don't have the linear rail mounted to anything. Maybe check what kind of rail they use. Maybe you can copy that approach, because I think that's really, really elegant if it works. Okay. MGN 15 is cheaper. I think MGN 15 is just, I'm not quite sure if what it does to the uh, smoothness, basically. I'm not sure if the bigger ones have higher friction. It's much easier with the driver than with the words with the Allen wrench before, Allen key. Why shouldn't matter much? X should be light if you want speed. Yeah, true. For Y it doesn't matter, but still, like even if Y is very long, like the 8mm rods are still not stiff enough, most likely. You will definitely have some sag. So I would go with the linear rails. And you also don't have to worry about the hassle that I have here with the proper tension. Yeah, and with the rods here, what we also have, right? Like it's really hard to mount stuff to them because everything rotates. And that's a bit of a pain. Everything rotates. I already lost one of the already lost one of the rubber feet I put on. Let's mount that again. And then we have to put this back. Okay. So yeah, it's still like a bit wobbly, but 500mm linear rail enough for X and Y axis? You mean like one piece linear rail? You want to cut it yourself? I mean, it depends how big your printer is supposed to be, right? You need typically 2 for Y and 1 for X. Okay, let's turn it on and see what happens. 3 pieces. Well, 500 is then really long, right? 500 is really long. I thought you wanted to build like a 300mm machine. In this case, 500 would be like quite lengthy. Because if you check out the 2.4, I mean, it doesn't really matter. Just choosing any stuff. So if you want a 350, I think I would assume they use like 50mm extra. Yeah, 50 to 100. Oh, it doesn't load up. Okay. Yeah, but I would say like 400 to 450. Not quite sure. Doesn't load. So you know my approach. I always check like what other people do. Okay, let me quickly check what my router says regarding the Pi not being online. Oh, it's here. I just used the IP address. Okay. Some of this is a little bit weird. Okay, but it's here. No clue what the problem is there. So let's quickly check what we want to print. Cable is a bit on the rail on the belt there. Let's see what we want to print. So let me actually grab that spool holder in a second. And yeah, let's just do new project. Nope. How about we just do a Voron cube? Because then we have like straight sides. It's like always a bit easier to check like extrusion, I think, with that. We also didn't calibrate the Patch Advance yet, but I think like we should first get like some bare bone basic stuff printing. Born use 400 rails on a 350 app, so it's plus 50. I mean, basically it's the width of the tool head, right, that you use, like half left and half right. So if you have 50 extra, you can have like a... No, it's not even true. You lose the width of the mount of the tool head, not the full tool head. So with a 400mm rail and you want 350 build volume, right? You lose the 5cm of the mount. But I think it's always nice to have like a little bit of like left and right wiggle room, because then you can add like a brush or something on the side. It's always handy if like the printer has a little bit more motion room. Yeah, we need filament. And then I was thinking maybe actually we should quickly do that before we start printing. We still don't have anything here Bowden tube wise. Maybe it's good if we just like doctor Bowden tube to the end here. I have a bunch of Bowden tubes, but none of them is like the bigger diameter. Like usually for reverse Bowden like that, it's always good to have like not the 2 mm internal diameter, but the 3. So that yeah, there's no friction because there's not really like point in having it super tight. I think this should work well. Let me just replace this here with a zip tie. Let me quickly turn off the motors. Then we can like quickly change the check the motion. Yeah, but it looks good. Yeah, that's long enough. And we can just zip tie that here. It's just okay, let me first tighten it a bit. Put that through. Here we go. Okay. That Bowden tube was not very into into being mounted there. And I just check that this is not touching the belts here. Still a bit like preliminary setup. A resolve screw with NEMA 70 motor and 2x8 linear rod with bearings good enough for that. How thick is the bed going to be? Steve, I think the 2 screws is the lead screws. So basically, you want to do the same here, right? That you have like 2 smooth rods to like guide it up and down, and then have the lead screws. The thing is with the lead screws, I would do at least 3. You have to do at least 3, because if you only have 2, the force of the bed, basically, let's say like the screws are in the back, right? You're pulling the bed on the back, but on the front it will like go down a bit. So you have tons of friction here, and the bed will not move. You need at least 3 lead screws. You need 2 in the front and 1 in the back center, ideally, or 4 on each corner, 1. But only 2 is not enough, especially if you have such a large bed. For the V0, for example, it works because the bed is relatively small. But anything this size or up, you definitely need more than 2. I did a stream, you need to check like a while ago, like where I tried whether I get away with 2 belts. I wanted to have the same. I wanted to have these 2 belts in the back, but nothing on the front. And we ran in exactly this issue that basically you pull up on the back, and then this yeah, just like locks up on the rods, because like all the force comes from the back, and you have a really long lever. Yeah, so it's the exact same that you will face. Just worse because the bigger the bed, the more lever you will have. Okay, let me quickly grab the spool holder, and then I think we are ready to print. Actually, let's already start that print. While I grab the spool holder. So let's just print that. So that starts, and I'm back in a second. Okay, this is our really cool spool holder here. It is minimal. Whew. Yeah, I'm not sure if this is like ideal, but for today's stream, it will be good enough. I will make one of the fancy ones with the. Okay, yeah. I don't think this actually works. Yeah, maybe it just barely works. You just put it outside here. let's just say the cardboard spool is also maybe not the ideal matchup. Yeah, should work. And snip off the. So 4 lead screws and 2 NEMA 70. Oh, well, ideally you would just have one motor per screw, because then you can like automatically level the bed. Mm. 8 mirrors are going to be small, even N5 runs 12. I run 8. I run 8. To be honest, I think, Steve, like to only hold the position in X and Y, 8 should be fine. Unless you're going like really tall and maybe it gets too wobbly, but I think like for like the vertical, just like to hold the bed in the right spot, it should be fine. Go with 3 and 3 motors like Warren. Yeah, exactly. One motor per screw. And then, yeah, the question, if you want to do 3 or 4, I think 4 is easier to implement. Because just like on each corner, one screw, it's like not as ideal because it's a bit harder to like level, but from building, I think 4 is easier than 3. Yeah, the Trident would be. Is there a 350 Trident? Do they go that large? But yeah, Trident is like exactly that. Like they use like 2 in the front and 1 in the back for the screws. Um, yeah, there's a 350. Okay, let's see. So I'm cautiously optimistic. I see a lot of material already being pooped out. That's quite the purge line. Well, that did not last long. Oh, it's way too low. It's way too low. Yeah, I just like hit like plus 250. And I think it's still too low. Oh, I don't really have it focused. Yeah, it's still too low. We really need to get the probe up and running. Can we just like roughly like get that at the right set, and then we can just start over quickly. Yeah, I think. Let's just try this again. We have the homing routine in a way that if the printer's already home, we don't home again. Which actually makes it quite quick to restart your print. I like that. But also like it's if your Z offset is a bit inconsistent, once you have it dialed in, it should be dialed in. No, we are too high? No. We're still a bit low. Oh, sorry. Even less focus. Bit hard to see without the toolhead light, to be honest. I really miss the LED already. Yeah, I think we are getting like a somewhat okay first layer. We really should like start doing like not a brim, a skirt. Because I feel like the center was not really like ready yet to extrude properly. That's quite a crappy first layer, but should be good enough for our little experiment here. The last nozzle was tied to the block. This isn't. Yeah, exactly. Exactly, Steve. I think you diagnosed the issue correctly. I mean, it looks better than before for sure. Not saying this looks good, but better. Okay, I'll just like help a bit with the filament here. Yeah, I mean, like the first layer was quite crappy, but now it kind of gets quite consistent. Good surface. Let's just do that for like a couple layers and just see how the outer wall also looks. But like, just like from the how the surface looks, it is within, let's say, like 15% plus minus of the proper extrusion value. And I don't see any areas where we have like under extrusion. I'm a bit confused because it never like does the inner circle. Let me just quickly check the G code. No, it definitely should like do the inner wall. But let me quickly already add the skirt loops. Because otherwise we will forget that. I like my skirts. Yeah. And how about the fans? One fan is already not spinning. Like this one is spinning, this one is not. So the cooling, that might also explain the cooling. So those fans are absolute shit. There's not a way to say it. Like it's 2 out of 3 fans, assuming it's not the connector that I crimped, but I think the connector should be fine. And 2 of 3 fans are already defective. I'm still annoyed that like I misplaced those fans. Let alone if I trash the fans, then I'm really annoyed. Hi there, Steph. There's still a bit of under extrusion on the outer walls for sure. Okay, but I'm also like the center is like really messy and I don't quite understand what's up there. Because like it you know, like it does the outer wall, like not right now it does the outer wall, but I never see it doing that inner circle. Like the inner like wall circle. Or am I blind? It's printing in a circle, but shit's cooling stops from sticking. Yeah, it could also like I think now it just did it, right? I mean, that would explain the mess in the center, to be honest. You know what? I wonder whether we can just like place a fan to just add cooling. I have something. Give me a second. I'll grab something. Steve, 2 stupid people, same thought. That's exactly what I had in mind. Because like that one is wired up. I have a power supply. I can plug it in. We just remove the filter. Now just need to figure out where to place it. It's quite a big fan now. Let's see if that does anything. There's definitely airflow. But I think by now it's just like so screwed up already that like maybe let's start over. Let's start over and try again with the fan. Or we can also just do something that doesn't it has like a bit like a easier geometry. Let it run. I can also let it run. You think it will correct? Because like here there's just like such a mess. I wouldn't know like how it can start. I mean, if it would have proper cooling, like most likely it will start laying that circle, but I had a big city tours. Let's just quickly start over. Oh, but it's also under extruding. Or no, it's too high. That's also like, let's quickly check this out first. So we can, so it's definitely like, it's basically like completely see-through. So it's definitely under extruding like hell. Which explains already most of the issues. So I'm not quite sure if the, we did calibrate the extruder distance, I think. Let's just recalibrate the extruder steps quickly, just to be sure that this is correct. And then see what that does. This is like a really tight fit with this bone. Okay, let me just snap this off because we don't want to have the drag of the. Okay. I need a ruler. That's a long one, but we'll take it. Let's just do that again, because like last time we did it for short, and also we had the issue with the extruder, so it might have messed up the result a bit. Okay, it's marked at 120. Let me just quickly copy the commands again, because I'm always forgetting about that. Tuning, extruder calibration. G1 E100 F60. G1 E100 F60. Off we go. Oh, that's the wrong printer. Let's try this again with the correct printer, right? M83 G1 E100F. F60 is what I wanted to say before I accidentally pressed enter. Let's quickly. Okay, let's set it to 225. M83 G1 F100 E 100F60. Let's quickly double check. I don't think it pulled in any filament really. Let's just double check. Yeah, I pulled in a tiny bit. So now the top of my mark is what we will measure later on. Instead of the bottom, it's now the top. Okay, let's... Temperature is there. Yeah, let's extrude. It's very slowly pulling it in. And we can just like double check that that is correct. And if that is correct, so I had something funny with this filament on the V0. It was also under extruding a bit. So maybe the filament settings are not correct, which would be weird because I printed that quite a bit. But weirder things happened before. So let's see. Still pulling slowly in the filament. But like also the extrusion looks like much better now. Just like from the consistency what comes out. The filament might be a bit wet. I hear like very slight popping sounds. We can also maybe try like a different filament in a second. Although it's relatively new. That's the thing, right? Like with the micro Swiss Hotend on my ender wire, I had also like these popping sounds, and I always thought like the filament was wet, and I was going crazy over that. In the end, like it was the Hotend pulling air, causing the popping sounds. See, should be almost done. Tiny bit more. I think it's done. So it pulled in 1.5 millimeters too much. So it's actually like pulling too much, not too little. So let's quickly check the formula. So it's previous rotation distance times actual divided by 100, and the actual was 102. So where is the extruder? Here's the extruder rotation distance. So the previous was this times 100 divided by 102. Let me just double check the measurement. Yeah, like 18.5 is left. So the new extrude distance would be this. It's a tiny bit less. But then basically my question would be if we're already over. I mean, the other option would be that our Z offset was incorrect. Also possible. How about make a new print, but like not like a three-dimensional print, but just like a first layer? Did you do a hot tighten on the nozzle? We didn't remove the nozzle, right? Like it's a brand new block with the nozzle pre-installed. We can do a hot tighten if you want to. We can do that. Just carefully push down the bed a bit more. Hot, hot, hot. I could have grabbed a proper tool for that, but yeah, that is tight. I think it moved like a teeny tiny bit, but not a lot. Okay, let's just try like a first layer that's a bit bigger. Because also the cooling doesn't matter. So let's just make a new plate as primitive cube, and then we just scale that to, let's say, 50 or 60 by 60, and then 0.2. Now we just have like one layer. Let me also quickly check what the first layer height is. 0.2. Let's put it to 0.28. I should just save that. So let's just print that and see how that looks. It's a thing now, right? Like if we are not certain if the extrusion is correct, let's just tune the first layer a bit. What size nozzle and temp you're running? The nozzle should be 0.4, and temperature is 225, which is like I used that filament a lot. Like I think I printed like 10 spools of the filament by now. So the profile should be quite okay. No, we kind of should also like feed filament maybe. I mean, another thing that could happen here is that like there's too much friction in the filament feeding. Because like our spool holder is definitely not ideal. But to be honest, like I think the temporary spool holder I used last time had less friction than this one. This spins much better. Like if I just ignore the chaos in the background, like this spins really, really good actually. So I think I'll just use this instead of this like minimal spool holder. That might be better with like with plastic spools. That might work quite well. Upload and print. Oh, it's already printing? Oh yeah, we are preheating the bed. Oh, there we go. Let me just actually give you like the top-down view. Might be the best for the first layer. Remove the Bowden tube and see if it's a friction issue. Yeah. I mean, I was thinking kind of the same, right? That's why I removed the holder here. But you might be actually right because like, even now it's relatively. No, it's quite okay to pull, but still, let's just do the following. I just pull like a bit of filament here. We just pay attention that like there's always like some filament like in this like loop here available. Oh, I paused the print now. Okay, let's resume. And yeah, it's oozing during travel. And now it's like way too far down again. Let's see. I'm at like plus 250 now. So basically full first layer height higher. Let's actually save that because like we homed now multiple times and it was always way too low. Looks kind of okay. Still, I think the height is relatively okay now. Let's maybe go like a teeny tiny bit higher. Plus 0.01. There's still like tons of like filament to pull here, so we don't have a friction issue yet. But yeah, and basically like for the Warren cube, most likely it was a combination of cooling and just like under extruding why it didn't stick in the inner ring. Yeah, it's kind of like okay first layer. I'm not quite certain if it's really like, I mean, like from the extrusion, we definitely have to like tune the pressure advance. That's like why it has like the bulges on the sides, and in the center it kind of is more or less okay. And the bed is quite level actually. I'm like, I mean, it's a relatively small area, but like it's quite level. Make sure that there's a filament here. I mean, it looks fine. So I would just save that offset now that we have. So I now saved it at 265. And then we can save config after this beautiful print is over. And then I would say, let's just try the Warren cube again. Let's just try the Warren cube again. How many smooth rods are required for the Z-axis if I use 3 lead screws with NEMA 17? 0. You don't need any additional lead screw, any additional smooth rods if you use the lead screws. Depends most likely a bit on your bed mount, but as Steve suggested, if you go for 3 lead screws, just copy the Trident bed mount. You can basically what you can do is like your bed assembly can be one-to-one the Trident bed assembly. You don't have to design it yourself. If you have the 3 lead screws mount to your frame, you can just copy the Trident bed. You can save like lots of work, and it's a proven design. Yeah, it's actually like quite level. I mean, you really see like on the corners, there's like pressure advance issues. So maybe we can even tune pressure advance. I would be cautiously optimistic that we can do that. Let me do something that I usually don't like to do. Let's just quickly measure, paying attention if we don't measure the side. But this is now, I mean, yeah, like this is never like very precise. That now measures in at 0.37, so it's a fair bit taller than what the first layer should be with 0.28. But then that would like rather speak for over extrusion. But it's always like a bit difficult to measure like this, especially now because it's wrinkled. But let's assume this is kind of okay for now. And let's quickly print that Warren cube again. Let's print that Warren cube again. Where am I? Prepare. Let's just switch over to this plate here. Slice it again. Oh no, we want to do pressure advance, right? Let's do pressure advance first. Calibration, pressure advance. So we go for the pattern. And then let's just start with the default values and just see what that does. It's not saved that, slice plates, and then we will get this pattern for everyone. I think everyone saw it by now. But yeah, it just prints these arrows. and change the pressure advance according to scale here. The Trident doesn't use rods, it uses rails on the Z and lead screws for motion. Oh, it actually, okay, I've never built a Trident, so it has something to hold in place. But in to be honest, like if you use already rails for the for X and Y, I would just, whatever you use for X and Y, just also use it for Z. There you don't need any extra parts. Let's see. I'm also not sure, like, you see, like there in the basically down there, there's like a little white window which is fusion, and I have no clue why it is a fusion window. It's like hovering there in the stream. I have no clue where this comes from. Ah, there it comes from. Okay, weird. Huh. So I'm just like keeping this in this position here. I think it's quite good to see from above. And then I'll just try to focus here on the front of the bed. And it should stay focused. Let's see. Should start any second now. Takes really like its sweet time to like settle in the temperature. So we should maybe do like pit tune. Although like once it has the temperature, it kind of looks fine. It's just like it overshoots it quite a bit and it takes like a while to cool down again. There we go. Now we'll still make sure that there's enough like filament here. And then maybe later we can just attach the mold tube and compare. But I was very certain that I still had like the 3mm, the 2mm Bolden tube. Because I ordered quite a lot of that. But all I see is the 2mm inner diameter. We also have quite substantial retraction. Let me quickly check what we have as a setting there. Retraction is 0.8, which we can also tune, of course. And we have Z-top, which could also explain some of the stringing. Z-top 0.4 is quite aggressive. And what annoys me a bit is like that the cable back here is like kind of grabbed by the belt a bit. That's something we need to fix. Not a big deal right now, but like. And at some point, maybe we can also add some cover for the exposed screws for the heated bed. Here we go. 0.2 or to 0.4 direct drive. Yeah, so for our direct drive, usually it's lower. I mean 0.8 is not like completely out of the ordinary, I would say. It's like definitely the high side. I have no clue I have no clue how we set up the machine, because we like kind of went through this like Orca process and it was quite iffy. But you definitely see like it's like there's a lot of like stringing. So it's definitely not okay. So looking at what we have here in Orca, it's like 0.8 retraction, 0.4 Z-hop. So I think let's just try the pressure advance first, because pressure advance also helps a lot with that, or like changes that actually. And then afterwards, maybe let's just do like a quick retraction test with the tower. Turn the heat down. The heat is fine. Like this material is tuned in. Like given that the Hotend reports the correct temperature, 225 for the filament is fine. But yeah, like if you want to reduce the stringing, you can also reduce to like 210 or something. But at 210, it doesn't have enough flow. Not for this machine, but for the other machines. But I know that like the 225 for the filament is fine. Like it can handle it. And like for me, like the filament is kind of like the known constant, right? Like I print with this filament. So I know that the filament is fine, like filament settings are fine. Because I printed on both my other printers, that's fine. So if it doesn't work here, it's not filament setting, it's the printer. Let's see, I think like the next layer should be like a bit faster. But also you see like the higher pressure advance, like there's less stringing here on this side. Prints this game. To be honest, like this doesn't look too shabby. Like besides the stringing here, like it looks really okay. And we didn't have any clogging, so I think like definitely like Steve, you were correct, and like the nozzle was tightened against the heat block and not against the heat break. Yeah, the string just makes it a little bit harder later on to like read the result most likely, but should be possible to get something out of here. Just checking if it like roughly represents what I would expect. But we have under extrusion here. It's under extruding quite a bit. I'm quickly pausing. Like there's a lot of under extrusion here. You can see like all the lines are separate. It's a bit hard to see on camera actually, but they're not connected. So maybe we're going too fast. I'm not quite sure because we're not going super fast, but it's like a super crappy hot end. So potentially that's already like the limit of its extrusion capabilities. It has a bit of cooling on the side. Is it pooping or is it extrude skipping? It doesn't skip. I don't hear any skipping. And my suspicion is that it's a hot end because the extruder is like a normal like mini stealth burner extruder, so it should be fine. And you also didn't have any issues on the first layer, right? The first layer looks fine. Only like when it's sped up on the second layer. Actually, like let me quickly peel that off and we start over. Because then we can compare the bottom. Because like the bottom looks fine. Like this looks okay. There's like, I mean, you can always like argue with the Z offset, but it's kind of fine. It's really just like the second layer that has the separation of the lines here. So let's try this again, but this time we slow it down on the second layer. So I'll just cancel it and print again right away. Nope. And the Z speed is a bit crazy. Need to change that. It waits for the extrude to cool down. That's not quite ideal, but let's give it a second. And then we do the first layer, and then we just slow down to 50% or something, which takes on a little bit longer, but then at least we see if the issue's still present. But then basically, even now with the filament not being pulled in from the bone directly, we still have under extrusion. I wouldn't tune filament with the P8 template. But we're not tuning filament now, right? We're just trying to figure out the pressure advance. Or am I missing something? Like my goal is just like to figure out the pressure advance. The filament should be fine. Also, like we did the first layer, right? And we also did not have any under extrusion here. Like this is totally fine. Technically, it's more like over extruded because it's thicker than what we aim for. So I think it's just the speed at which we were like doing the lines. You're looking at the line width, lines not touching. Yeah, but we saw the same with the cube, right? And also here we had like a lot of under extrusion. So yes, I understand like that technically we should first maybe like address that issue. But I think this is like as good as any other print figured out. Like the first layer, like in all of them, except for the cube maybe. The cube still had like under extrusion on the first layer, but it could just be like the Z offset. It kind of is fine. Let's do the following. Let's try this one more time, and I slow it down to 50%. And if we still have under extrusion, then we just go to cube and first figure that one out. That's what I'm trying to say in 2 words. Okay, then we are on the same page, I guess. But also here, like right now, you see there's no problems with extrusion. Like this looks totally fine. So I don't think it's like a general issue. It's just like potentially just like the speed. The hotend is super crappy, so I wouldn't be surprised if we have issues there with the filament not getting enough heat quickly enough, and then you just get like extrusion issues. That would be my assumption, that like just like the heat transfer is really bad. This is a €5 hotend, so I've actually was like this close to like ordering a Revo with the PZ probe, but they're not available until November. And I don't want to buy now like a normal Revo heatsink because I know I will not use it. So I hope that we get by with this hotend for like a little bit before I then spend proper money. Maybe that means we have to print a bit slower until then. Let me just quickly check. So right now, if we do this like line, we have a flow of like 3 millimeter per second. Cubic millimeter per second. So 3 seems fine and doable. But I think the second layer has much more. So maybe we can... I bought a copper titanium. Sounds expensive. Sounds expensive. I think the silver one I have over there is also titanium, but it's leaking, so it's not really good for anything anymore. Maybe I also buy like a temporary hotend, like some V6 clone for like €20, but then it's already like too much money for like a temporary solution for a couple of weeks. And I need my other 2 printers at the moment. Otherwise, I would have said like we just like steal the tool head from one of them and put them here. One thing that actually we can do maybe next week. That was on my to-do list anyways. I got a second one of the EBB 36 that we have here. So if we actually put the EBB 36 on my V0, we could also just use the V0 toolhead on here because I'm fine with that temporarily attaching it here. It's the same toolhead, so it's one-to-one like drop-in replacement if it has the same board. That would be actually quite fun. Then we can like swap the toolhead, then we can like use the Revo Hotend here. And then after the stream, I can just put it back and everything should be in line, hopefully. Try to focus on something where toolhead is not. Okay, now slowly get ready to, I would just, yeah, we now hit like 3 cubic millimeters per second. So let's just slow down to kind of hit the same flow rate. Then we're certain that this is not a problem. I'll just start with 50% speed and then we can like see where that leads us. Oh, maybe let's do the numbers quickly. Yeah, also here we're like around 2. And now we are around 4 cubic millimeters per second. So I actually do it like a bit slower because I really want to remove that as a variable. Yeah, now we're around 3 cubic millimeters. I'm not sure if this looks better. I mean, the other thing we could do is like we could do the max flow rate test. But it would be like, usually I wouldn't do this early. Okay, let's let it run and then we can see if we get something out of that. I'm actually a bit bothered by the gold. Like I know it's prototype, it doesn't really matter. But if we later build this properly, like I definitely like paint these studs. They're black. And the Z-hop is quite extreme actually. Like you really see it like doing it. I mean, we can already like disable that. I'm not a big fan of Z-hop. The only time when I use Z-hop is if there's something like on the bed that's easy to knock over. And on top surface, I always have it on because otherwise you get the streaks. But generally, I don't use Z-hop. I think this has like 3 layers, so this should be like yeah, this is the last layer. Man, it looks super messy with all the all the streaks there. Z-hop can also produce stringing, what we are seeing. Yeah, that's also why I want to disable it. And also like 0.4 millimeter Z-hop is really extreme. Like usually 0.2 is like maximum, right? I kind of want to focus on one thing at a time. So right now, like I'm kind of like want to get this pressure advance, at least like idea what value we need. But I think like afterwards we should definitely look at the retraction next because this makes everything super messy. We can also give it some cooling now. Oh, this way. Yeah, but we are still like, we still have under extrusion on the lines. Like if I look here from like directly onto the line, it's still under extruded. Yeah, it's almost done. Let's have a look. But yeah, let's maybe like the things, there's so much like oozing that I also maybe it's like because there's so much filament like leaving the nozzle between the stop and start, like during the retraction, that potentially that also just causes the under extrusion now here. So let's just, yeah, let's actually just figure out the retraction first. That should be it. You're done? No? One more? Yeah, but yeah, that has no point. So I'm not quite sure if there's anything we can read from this mess. Because like technically we would look for like bulging and gaping. But this doesn't tell me anything. I'm not sure if anyone in chat can read something from this, but the only thing I can read from this is that we have like tons of stringing. Just quickly get it off and like look at it. Like it's weird because like the first layer is really like okay. No, there's nothing you can read from this. There's nothing you can read from this. Time to open Ellie's site and tune. Well, we are on Ellie's site. No, there's really nothing you can read from this, except that the first layer is definitely like too low now. Like this looks like a bit translucent almost. Like this corner here is like almost translucent. Okay, we know that the rotation distance is correct, so that's what AZ Cowboy suggested and return to our favorite side. So technically, like from the steps in tuning, we calibrated the extruder. Build surfaces first is fine. First layer we kind of did, right? We printed the square, which looked fine. And also this looks somewhat okay. I mean, looking at this just might be like too close to the bed now, and that's why we don't see the under extrusion there. But yeah, it kind of is okay. So first layer, I would say like it's okay. And then we have pressure advance. See, that's exactly what we're doing. Extrusion multiplier is something like on a filament basis. Unless we want to tune like top layer and stuff, but that's almost a bit too advanced. Cooling is non-star at the moment because we have like super crappy fans. And then like the next one would be technically retraction if we are kind of like quickly flying over that. So pressure advance, the problem is like really like this is not good enough to read anything from that. And like the main problem I have with this print at the moment is the stringing. Like there's so much material here that I'm really not certain if that is actually the problem. So let's do the following. Let's really just quickly do the retraction test. And let's quickly start a new project because otherwise all the settings are messed up. So I agree with Steve that we should remove the Z-hop. Or let's leave the Z-hop at 0.2, but then do only top surface. That's usually what I do. Oh wait, sorry, you're in the wrong. Only top surface and 0.2. That's usually what I have with all my printers. And the retraction length 0.8 seems like really like a lot. So let's just put down to 0.4. Save that, and then let's do just a quick retraction test with the tower. 0.1 millimeter steps from 0 to 1 millimeter. I didn't cancel the print yet. And man, this bed goes fast. This is a bit scary. Yeah, there's so much stuff going on that like even if there wouldn't be under extrusion, like it would still be like really hard to see. No, actually, like what does he tune here with extrusion rate? Um, yeah, extrusion multiplier is a per filament setting. And again, like because I used this filament before, or like quite a lot, like this is set up correctly. So in the filament setting here, this is like most like 0.97. So this is tuned and should be okay. So all these settings, also temperature, like I don't want to change because like this is like a working filament profile. Oops, here we go. I'm not really sure if there's like a difference between like all metal hotend and the Bowden hotends in like a direct drive setup. Where you see like how much like there's zero retraction basically. Although like most like now it's running with zero retraction. I think it just applies like the first layer is 0 because it starts at 0. The Warren Legacy uses 2 lead screws with NAMO 17 and 4 smooth rods. Should I replicate that or use 3 lead screws with NAMO 17 and no smooth rods? Well, if you use 3 lead screws, then you basically replicate the Trident, right? And I think Steve said the Trident uses the linear rails. So, I mean, the Legacy is just a Trident predecessor, basically. It's the same printer, I think, right? Oh no, wait, the Voron Zero was the Trident predecessor. The Legacy is different. Yeah, also now, like, it doesn't look like under extrusion. Like, if it's not just a full thing. Yeah, something is fishy. It completely screwed up the bases of the tower. Like you see, like there on front. Oh. I don't think it can focus. Yeah, like there's like a complete gap there in front here. And ridiculous amounts of stringing. It's the ugliest retraction test tower I've ever seen. It would be really nice to just have a standard Hotend, because I think this is most likely just like Hotend stuff we're trying to debug here. Like from the motion, it looks fine. Like the printer motion system itself, like I don't think we have any problems there. Or like not at that speed. Do you have a way to check Z drop each layer? I don't have something to measure that. I don't have something to measure that. But actually, Steve, you might be on something there, because did we ever configure that properly? I mean, that wouldn't explain the Now here's the question. Does this look like a normally sized benchy, or is that like a bit stretched? I feel like it's a bit stretched, right? Like it looks a bit too tall. I mean, I don't have a perfect tool for that, but like we can do something. Okay, I think we can cancel that. Like that is also like not giving us any information. Let's do the following. That's not perfect. But let me just move the tool head maybe not quite to the front. Because I think, Steve, we did not configure it properly. Let's just quickly check the configuration of the vid here. So we have the stepper Z and Z1. But I think I just copied that. So the rotation distance 8 might be completely off. Let's just quickly test it. So what I can do is I can move that to, let's say, 20. How can we do that? I mean, it will not be perfect. What? I'm looking for a way that I can kind of position. From Xrod. Yeah. Oh, it's actually a good one. maybe that's it's not perfect. That might be the best we have. So if I position this here, the it's a bit too short to like properly bridge the gap there. So this is now 65.4, which is nice because we have 11.4 here. So if I now move to 12, now we are at 66.65, so it's definitely more than a millimeter. I mean, it's not super precise what I'm doing here, of course, but let's just move to a little bit more. So I'm moving to 15. So we should end up at 69.6. And we are at 70.27. So we are like 1 millimeter over, which definitely is like, maybe let's do the opposite way. So if I now move, so now we're at 70.3 basically, 70.3. And I move to 2.4, 2.4. So we should be at 57. And we're at 54. So it's definitely like 3 millimeter off. So that's not correct. So we screwed up there. And by we, I mean me. I just like to share share the blame. Okay, let's figure it out. So rotation distance 8 is definitely not correct. So technically first, at the first step, we have the same rotation distance as X and Y, right? Because we use the same pulleys. So the rotation distance is not 8, but it's 40. And then we have a gear ratio. Let me quickly check the clipper config. Config reference. Where's the stepper? Stepper Z. Stepper section. Where's the stepper section? Stepper. So we have the rotation distance and there's the gear ratio. So now the gear ratio should be relatively easy for us to figure out, right? Hey there, Science Sniper. So the gear ratio, where did I set rotation distance? Here. The gear ratio is we have 16. Is this a 16 tooth pulley or is it 20? What is the normal pulley? It's 20, right? And the large one, we need to figure out how many. The large gauge is the same as might be the same as the V2. It's the same gear as the M4 extruder. It's the same as the M4 extruder. Gear ratio. 4-to-1 ratio. Features 4-to-1 belt-driven design. So the gear ratio we need to use here is 4-to-1. Because it's exactly the same setup as the M4 extruder. And that should be it. I think this might explain a lot of the issues. The only problem is now, like, we will screw up a lot of things if we do that. Yeah, and the rotation distance is only a bit off now, right? So because the rotation distance before was 8, and now we have a rotation distance effectively of 10, right? Because we have the gear ratio 4:1. So basically, it's a rotation distance of 10. So we are off tiny bit, which explains why it's almost correct and it didn't like really stand out. What's the Hotend? It's a standard stealth burner, mini stealth burner. Nothing fancy. Just a normal mini stealth burner, but with a really crappy cheap Hotend. Okay. Let's just let me kind of move it down a bit, and then home that I'm like really quick with emergency stop. What kind? It's a very cheap Ender 3 clone. It's extremely shitty Hotend. It's this, basically. It's like the most crappy Hotend imaginable. I will replace it. Yeah, it's just like the Ender 3, but not even like a original, just a clone. This project started out as like super low cost printer. So I basically shop for like the most cheap parts possible. And while most things are kind of like proper by now, like some cheap parts still survived. I will, once I know this is kind of like more or less a suit like workable printer, I will buy like a nice Hotend. Yeah, it's a regular Ender 3 Hotend, but like a clone basically of that. It's not like original Creality. I don't think it makes any difference, but okay. So the problem though is we completely lost the Z movement most likely. So now it thinks that it is at Z125, but the problem is now basically if I move it up to, let's do like to 40. We need to be really careful to not ram into the nozzle. Oh, also, this is not straight. Shit. Oy. Oh. So one motor now does something else than the other. What happened here? Set. Where did I now set the rotation distance? Stepper Z has it. Z1 doesn't have it. But now you saw like the two steppers completely out of sync. So the change we did definitely does something. Wait, gear. Z1 has a gear ratio. Extruder has a different gear ratio. Z has a gear ratio. Okay, so for some reason, like I didn't set it for Z1. Should I go with 2 lead screws with NEMA 17 and 4 smooth rods, and later add a third motor in case the bed is not stable? Well, if you have 4 smooth rods on each corner, the bed will be stable, right? So you have the lead screws left and right, and the 4 rods on the corners, it will be stable. That will be solid. The only problem is if you only have 2, it's the same setup that I have here, right? Like 2 motors, one left, one right. You cannot fully tram the bed via the motors. So with the Trident, you, for example, which has like 3 lead screws, right? You don't need the bed springs because like the printer can automatically adjust the bed level with the 3 motors. So I would definitely go for 3 motors, and then do whatever the Trident does. I think that's the best setup you can go for. Okay, let's quickly do that again. And I Yeah, now it moves down parallel. Okay. Okay, then let's quickly try again if we move to, we already moved to 40 and it worked. Yeah, now both motors work properly. 20. Yeah, now we are like way, way lower. Let's see. So we will need to set the minimum position here, because otherwise we will not be able to move up. The position min at the moment is -5. Let's just do the to -100 for now, just to find like a rough range. And then we need to do like the probe, like the Z offset basically. So I'm quite confident to moving that to -20. Yep. I got nervous. I almost clicked emergency stop. Nope, that was the wrong. I just want to get like a rough idea. Okay, so we are -34 at the moment. Let's do our paper. I hope I have a piece of paper here. I do. Oh. What was it set? Probe adjust? No, we don't have probe. Oh, set and stop calibrate. That's what we wanted. Okay. I'm just trying to get like just a tiny bit of resistance. Three months without linear work. No, that was my mistake before on. So you definitely need something to hold it in place. So basically, these screws will do the up-down motion, but you need something to hold the bed in the like XY position needs to be stable. That's what I do here with the two rods on the front, right? These two right on the rods. So the bed is like fixed in the XY. And then I have the four belts to move it up and down. So you definitely need the rods or the rails. And then you can have 2, 3, or 4 screws. But technically, like 3 screws would be the best. Okay, so we have very rough idea now where we need to be. So Z is -37. So what I would do is let's update the Z distance here. So position max is not 155, which like I already always had in mind like around 180. So it's 155 plus 37. So it's like 192. And then let's just set -3 as the top. Okay. Let's quickly home again. And I quickly want to do the Z position again, just to be sure. And then we can technically print again. And I'm pretty sure that the under extrusion might be gone then. Because basically what just happened? I heard some weird sound, but I didn't see what happened. Oh, we didn't set the Z end stop position. Position end stop. Is 192. Now it should be basically like when we go to 0 in Z, it should be around 0. Okay, let's just bring that to 60 millimeters. We center that. And then we do Z and stop calibrate. Okay. So Z and stop is calibrated. And then I would say let's try the retraction test again. Let's try the retraction test again. Because the retraction test is still like quite crappy, most likely. But now at least like it might be better than before. Not with the retraction, but just like the general printing. Also, let me set the maximum Z speed because this is like insane. Like after the homing, it's like. Also quickly delete the backups. And then let me actually download the whole thing because like I broke already 2 SD cards here. So just so that I have a backup. Max Z velocity 150. Let's just set it to 100. Okay, so this heats up. And then we should have a retraction test. And it's also like really now like looking at this benchy, like it's like definitely like stretched. Like it's like taller than it should be, like the proportion is off. Yeah, and that also explains the under extrusion above layer 1, right? Like layer 1 was kind of still okay because we tuned that. But then every time it moved one layer up, it moved like more than one layer up. So the higher we go, the worse the issue should be actually. Which kind of reflects here. No. Actually, I'm not gonna trash that. This is like the first print. We need to keep it. That's a special place in my heart. After the stream, I will do a pit auto tune. I'm just checking. One thing I also did between the streams is I adjusted the position of the pulleys in the back because we had some rubbing on the not idlers, on the bearings here. But the pulleys are now like the belt runs pretty much center, so that's good. Oh, that's too low. It's way too low. Yeah, it's like you see like there's zero retraction. Okay, it's kind of okay for the first layer now. Wait, you need a front view for this one because it's too small. Hi Dave, I've been trying to join PT made out of bottles. It always snaps in its brittle after trying to join. I've never worked with PT bottles. Like that was kind of like on my list for project I kind of wanted to do, but like it never materialized. I have no clue about that. I know that PT is not a perfect material to print. The second layer now looks kind of okay. Still looks funky. I mean, retraction still doesn't work. That's like a different topic, I guess, but I just wonder if the ender hotend needs just like a lot of retraction. Let's just quickly see if like the end result looks at least like the shape it should look like. I was thinking of just it prints good, but I need more length. I think I'm just going bone. Also, you mean like the filament that you made from the PET bottle is not long enough? Wasn't there this like that thing was like all the rage in the last couple of weeks, right? A Sunlu filament connector. Seemingly works really well. Not sure if you tried that. But they use like these little Bowden tubes to connect it. They don't show how it works. Okay, cool. Never mind then. Maybe that's worth a shot, but then yeah, it's quite expensive. How's this doing? So I can at least like now recognize the shape of the retraction tower. So I think there's progress. And I think also like the higher retraction values have better, less stringy. Like it looks a little bit better towards the top, but might be just my imagination. Mm. I wonder whether we should just try like super high retraction values, like 2 millimeters or something. Just treat it like a Bowden setup. Maybe it's worth a shot. So we do calibration, retraction, and instead of 0 to 1, let's just do, because we kind of like ended 1, we do 1 to 4 in 0.5 steps. So just like have it quite long. And just see what that does. This looks still like really horrible. Yeah, it just might be just the hot end being I'm not sure if that's getting better, like with higher retraction. Looks kind of all the same bed. I think that's stand. Okay, let's not lose any time for it to cool down. Like this is a disaster. Let's just right away print another one with like super long retractions. I have like very high respect for this bar here in front. Like this bar, you really need to be careful like where you place your hand because your finger can really easily get snapped here. Like I'm not a fan of that. I initially didn't want to add this bar to the printer, but then like the sides most likely would be like too wobbly. But I think it's a good thing that V0 doesn't have that because it's not like nice. Yeah, like if you have your finger here, like this can really hurt. Bonus easy to load filament. Just use the detector when it runs out to add the next length. Yeah, I mean, that's definitely possible. What you could also do, maybe, depending what hotend you have, like for the stealth burner, there is a Bowden. Was it Bowden? Like, there's basically the mod where the filament sensors inside the tool head, so you can like really use the whole length basically, including the distance in the Bowden, because then you have still direct drive, but the filament sensor is basically inside. That was originally meant for the ERCF. That basically like the toolhead can recognize when the filament is completely loaded. I just don't remember the details of that. But technically, you can also just add like some small thing on top where the filament sensor is in. Let's see. And it always overshoots the temperature. That's definitely like a pit tuning issue. Oh, let me also like add some professional cooling when it's doing it. Maybe that helps a bit. Let me try to show it to you from the side. Yeah, I made one. Alarm goes off when the filament runs out. Yeah, and then you just have to swap it, I guess. It's a bit of legwork then, depending how long your filament runs are. And running over to 2, they do a filament sensor on top of the extruder. Yeah, exactly. The orbiter has it built in. Then you can really use the full run of your filament, and you don't waste like a lot or lose a lot. The base is going down well there. Yeah, like the base was always kind of okay. The first layer was good, but now we figured out like why the second layer onward wasn't good anymore. To be honest, like we can do the pressure advanced again, and most likely pressure advanced will work kind of okay now. Okay, so now basically we're doing retraction tests from 1 to 4 millimeter retraction, which is quite extreme, but maybe it needs that. Not even aiming for perfection here, right? Like I just like it needs to be like serviceable. The things like the motion system of the printer seems to work quite well. Like the motion itself is fine. Like it's not super fast yet. That's something maybe we can. I mean, I'm not also aiming for like speed race machine. But like it should be a bit faster than now. But I think like this is doable, and then I'm happy to invest money in like in a Hotend and fans again. Like the longer I think about it, I'm certain I just trashed the fans with the packaging material, which would really suck. No, what's happening now? Oh, I think we have a clock. Ah, we are printing. We are printing air. I said pause. Thank you. Yeah, it's clocked. Shit. Oof. Okay, at least clocked and easily fixable way. But I guess this is we need to start over. But yeah, it's better. Like the base looks quite okay. Like the bottom layer is good. Um, the top layer also looks good now. Like before we had on second layer, like always an under extrusion, the color looks fine. And what's noticeable, we don't have the line across with the retraction. Let's just quickly try this again one more time. Vertical speed is still a bit crazy. Let's see. I really like the mainboard, by the way. Like, I'm really happy with this one so far. It's so small, it has everything I need. Like, I was really considering just buying a second one for my V0 because I kind of want to move to Tucan anyways. And then with the SKR Mini, that SKR Pico that's currently in there, I need like external CAN board, and I'm not a fan of adding like more electronics to this like tiny printer. Like this would be like the perfect board for the V0. Yeah, see, as always, it overshot the extruder by like 2-3 degrees, and it takes like quite long to like come down. Uh-oh, it's clogging again. Like right now, like the first like line was like, yeah, now I see it again. It was like severely under extruding just now, like the outer line. This looks now kind of okay, but let's see. Maybe let's browse AliExpress. Maybe we find like some cheap V6 Hotend or something that I can order. I'm printing all day, making boxes and coils for my homemade metal detectors. I've been working in ultralight detectors. Commercial ones are so heavy. Sounds like a really cool project. I'm still doing this, by the way, to like eliminate any tension from the filament. It's actually like quite a quick printer already. Like my switch wire is not much faster, which I want to change, but for now. But it didn't do like this massive. I think the massive retraction issue is gone. Like because in the beginning we had like line from here to there to the back. Every time like after the skirt was done. That's definitely gone. And we're still having some string here, but it's way less than what we had initially, I think. I don't think yeah, it's still a lot of stringing. Oh, it's like super out of focus, sorry. Still a lot of stringing. Yeah, but I'm pretty sure it's something with the hotend. Like this is not. And to be honest, I don't think we should spend too much time on it. Like it's definitely better now than it was before. Let's just let this quickly run. Then we do the retraction up to 4mm. But I kind of feel like it's already clogging again. Yeah, we're already printing air again. Yeah, it's already clogged. So not sure if it's the high retraction settings. Because we didn't have clogging before, now we have clogging. And more or less at the same point. So my guess would be that it's due to the retraction settings. Then let's do the following. Let's just, because like the bottom one is 1mm here. So let's just go with, it's actually sticking to the bed quite well. Ah, come on. Thank you. Let's just go with 0.8 as it was before. Let's just go with 0.8 as it was before. Yep, there we are. But we removed the Z-top, so we only have the Z-top on the top surface. And then let's do the pressure advance quickly again. And see if we now have success with the pressure advance, where we had the issue that the second layer was under extruding severely, which we now figured out was due to incorrect Z configuration. Okay, and now let me also just connect the Bowden tube here. There's a lot of friction in the Bowden tube. There's quite some friction. Let's see. Let's try that. Let's do the overhead view again for this one. Let's see. like if you would have like more success with the pressure advance in a way that's like readable, that would be like a really big step. And then I think I actually would consider just trying the Warren cube again, because I think um let me necromance that from the dead. Looking at it now, knowing that the Z was off, I mean that could like we had like tons of like stringing issues here, right? Like that was not good. But I think the under extrusion we now figured out what the problem there was, which was the incorrect Z height, or like the Z steps were incorrect. And it actually kind of like reflects here, like the higher we went, the worse the extrusion got. So it kind of matches the. Now we have extruder skipping. We have extruder skipping. So this bonus is no bueno. Yes, yeah. No, no, no. Okay, so the bonus is not good. I will try to find some of the wide diameter bone. Let's just try this quickly again. You just have to pay attention that like the filament is running out here. Let's see. Also, like somehow like the color of the camera is like really off. Oh, that was the wrong button. I feared that would happen. Oh, that was the button I was looking for. Yeah, this is how it should look like. Not like this. It's gold, not silver. Again, you didn't clear. See, what do you mean? I didn't clear the cloth before the print? Ha! It does not. I mean, there's some stringing, but not by far not as extreme as before. So the Z top, because the only difference we now did is like we removed the Z top. It's the same 0.8 retraction. Like there's still like some here at the beginning. Still like it's way better. So the Z top already helped a lot. I mean, there's still stringing, don't get me wrong, but it's much less. So if the second layer doesn't have massive under extrusion, like I think we can actually read something from that. And then Warren cube time. But yeah, now it's also not clogging. So I think the high retraction values of like over 1 millimeter cause the clogging. Okay, let's just let that do its thing. You blamed Bowden, but you didn't clear. I cleared it in the back. I pushed it through. There was like the blob on the back. I cleared that. But the Bowden, yeah, the Bowden is it had extruder skipping. Like I hear it skipping basically with the Bowden. Okay. So while this is doing a thing, let's quickly visit AliExpress. So question is if we it's always like so annoying, like if you are not signed in AliExpress, like they show like complete random prices. I don't want touch. Okay, so now it's touch again. Okay. Language in AliExpress is such a pain. And pop-ups. Oh, what happened now? Lost communication with MCU. Okay. Okay. Let me unplug MCU. Oh, it didn't do anything because it still gets power from the power supply. Uh, failed to automated reset of MCU. Let's just quickly power cycle the whole thing. Let's just quickly shut down the Pi and just do the power cycle. That's new, like we didn't have any problems with that yet. Okay, let me just quickly cut power. But yeah, we can already, like, there's some bulging and thinning. So technically, like, the pressure advance thingy now works. Let's see if we get this back online. But yeah, like, maybe if I just order something like this, like a very basic V6 Hotend for testing, that might be better. I'm just not quite sure what the actual price is. Yeah, most likely this is the actual price. It's like €6. So yeah, maybe if I do something like this, then at least we don't have this like stupid Bowden tube there. Which might solve already some issues. Let's see. Let's see. Needs to heat up again, of course. I mean, at least the Hotend fans still work, so hey. Could be worse. Yeah, I'll just order something like that. It's not like a huge investment. And then it's not a good Hotend, of course, but like it's better than what we have now, and then like it will resolve some of the issues. Oh wait, this is also Bowden lined. No, I don't want that. This is also Bowden lined. I don't want the Bowden. Here, this one is what we want. Oh, this is a €6. Okay. Yeah. I'll figure it out later. But then I order something like, but without the Bowden. The Bowden. Um, okay, yeah, this will overshoot again. We have to wait for it to cool down. This LD for the bed, like this makes me crazy. I think I will just cover that later. Like this like blinking is like driving me insane. I'm back. Welcome back, Science Sniper. You missed the MCU communication issue. So we started again with the pressure advance. See, it has to cool down like 1 more degree and then we can, oh, there it goes. So just make sure that we have enough free filament here. Now also I'm building your printer. What printer are you building? Upside down portable 3D printer. But it's not the oh, what's the name? The one that folds down. Totally forgot the name. With the glass bed, basically. Tell me the name. Um, it's not a positron. Is it then your own design or is it like some community project? By the way, now the Z offset is like way too low. Oh, your own design. That's cool. Rapid box 3D printing. But does it also fold down or how did you make it portable? And is it already printing? That would be the next question. Let me just adjust the Z offset like a tiny bit more up. It folds, okay. Yeah, it kind of looks okay now with Z offset. But like, what's your progress? Are you still like in the designing phase, or is like do you still already have a prototype working? By the way, now we have the stringing again. I don't know, like it's kind of cursed. Let's hope like the MCU doesn't die. It's printing, yeah. Hi to MG Live. It's printing. Not well, but it's printing. We're kind of like chasing down issues, but like most of the problems we have at the moment are like centered around the Hotend, which is not really Ideal. I'm really considering just buying a new Hotend. I'm in a testing phase. Oh, really cool. So it's already printing. Are you planning on making it like open source, or like do you publish the design, or is it just like a project for you? Yeah, now we have like tons of stringing again, like super annoying. But yeah, let's see. I'm still thinking about that. Yeah, to be honest, like the things like if you publish something like that, I mean, I will publish it at the end, but you kind of have to provide it like as is, because people will then come and like they have issues, and then at least like I feel like I have to help them, and like it eats a lot of time. It's always the downside if you publish something, a lot of work comes after that. Also, like you have to like prepare the files properly and like sort everything and check the naming is correct, and yeah, it's actually quite a lot of work. Okay, we survived layer 1. But it's like really, this is funny. Like, I didn't see that. Like, the second half of the arrow is like super faint. Like, it's very, I'm not quite sure why that is. Like, it's like almost no filament here. Uh, see what it does with the higher layers. But this is like really weird. I've never seen something like that. Yep, the under extrusion is gone, so that problem is fixed. I'm making an Ender 3NG. Oh, that's also cool. Ender 3NG was the Core XY version of the Ender 3, right? The What if I use 3 lead screws and 4 smooth rods at each corner of the bed? There might be a bit too much on. The more things you have, the more things need to be parallel to each other. So you run the risk of binding. For my project, I got a 90-degree Hotend. Oh, yeah. Are they like commercially available? Because I remember for the positron, there was like some special thing they had to like create. But then what makes your printer different from a positron, like from a conceptual phase, conceptual like point of view? Like, is it the same way of building it, or did you change something? Yeah, now we don't have any under extrusion, so that's really good. At least, so if we fixed one issue today, we fixed that. MyScore XY. Oh, that's cool. That's cool. Like the positron had this like really funky belt system, I remember. Yeah, I changed a lot of stuff. Oh, it's cool. So really like your own spin on a portable printer. But imagine like I already struggled just designing a normal printer. It's already pretty hard for me. So I definitely I'm not up to the task of designing a portable printer. Are you like engineer? Do you have engineering background, or like is it just a hobby for you to design printers? Positron is Core H. Okay, no clue what Core H is actually. Yeah, I think now we can. Nice. Yeah, it should be possible to read something out of that. There was like some fun story like with the switch wire. Like I really struggled with the pressure advance tests. Like it just like I didn't get any information from the pressure advance test. Like every single line in this PA pattern, it all looked the same. I was going crazy. And at some point I figured out that actually the because I had the dual extruder setup, the pressure advance was not applied. Like so basically all the lines had the same pressure advance setting, and like that's why they all look the same because they were all the same. It took me like days to figure out like why my pressure advance was so weird. So I'm kind of like I'm kind of like a little bit like PTSD. I have a bit of PTSD when it comes to pressure advance tests and like that they don't look like they should look. That's I guess one more. No, that's it. Okay. Let me actually just keep the stuff at temperature already. Not I accidentally heated to hot to 250. Let's see. So stuff sticks well to the bed. Yes, that's good. Okay. Uh, well, what do I read from this? Again, that reminds me of the switch wire. I don't see any big difference between the two, between the rows. I mean, there's like this like annoying stringing, which doesn't help, but all the corners look the same for me. They all look the same for me. Like, there's no gaps, but there's also like no bulging in the beginning. Extrusion multiplier is tuned for the filament. High ballistic tech, by the way. That should be fine. Like we tuned the like the rotation distance for extruder, but yeah, this is not really helpful. But like the thing that we definitely fix is like the under extrusion on the higher levels layers. So that should be fine. So I wonder. Oh, I wonder what happens if we. Because I mean, we can print this again, but like, I don't see what I would change. I don't see anything we can read from that. So maybe let's just quickly try the boron cube again. Back to the start. Because now at least like we know that the Z stuff is working. Let me actually do one modification here quickly for the filament. I'm quickly changing the other layer temperature of the bed to 60 as well, so we can like quickly restart prints. Then we don't have to wait for it to cool down or heat up to 60 again all the time. Yeah, we should save that actually. So the flow ratio is tuned plastic tech for this filament. So it should be fine. Let's quickly try this boron cube again and see if we now get like anything that's remotely usable. Yep. Yeah, but now like this, I don't know like why the stringing was gone. Now the stringing is back. just give you a front is maybe better. See if we find some focus here. And oops. So for some reason, the first layer is now like quite inconsistent. It also used to be better. Let me add our cooling. Yeah, it's a bit of cooling with fan on the side. Really sorry, I don't know why the camera has like. For some reason, like the focus is not really doing what I want the focus to do right now. I feel like the inner circle is like kind of like really bad. But we definitely don't get the under extrusion anymore. So that problem, yeah, I repeat myself, but it's definitely gone. Yeah, like the circle in the center, you can just completely forget. Oh, sure. This fan is anything, but it's still a bit under extruding. Like in the front, the sides are okay, but like here in the front, it's still like a bit under extruding in the wall. So I'm not quite sure why that would be. And you also see like the walls are like a little bit like splitting apart. Let me quickly check what's up with the focus here. Yeah, let me quickly use menu focus. That's annoying. You can see like on the left side, like there's a little bit of a gap in between the walls. But generally, like it has a Voron cube shape. So I guess like compared to the first attempt, it's definitely better. Hi there, Cowboy. The angle of the PDF tube might have a tight curve to force it. Oh, wait. I did not pay attention to that. Yep, Cowboy. Thank you. I did not pay attention to the stupid PDF tube. Yeah, I definitely have to get. Step one would actually just be to get rid of this stupid like Bowden tube and just like have a loop on the back where the filament is pulled through. I will look for the Bowden tube with the larger diameter, the inner diameter. Welcome, yeah, thank you. I was so focused on the print that I did not look at that. I'll just hold in my hand here, then I feel when it's like coming up. Yeah, but it might have been like the under extrusion in the front. I think next time we should also install the Toolhead LEDs. I still have some. At least you can see a little bit better what's going on there. And I still hear these like very slight popping sounds from the Hotend. So I'm just not confident in this Hotend being any good / usable at all. Now I just remembered again that I lost the fans. That would have been much more fun with new fans now. Yeah. I mean, the inner walls are still like a complete massacre. I'm not quite sure why. Like, I think partially it's cooling, but even without cooling, like, it should be able to, like, draw a circle, right? Or, like, print the circle. And also, like, I'm still not sure, like, when it's supposed to, like, do this inner circle. I never see it, like, doing this, like, circle movement in the inside. Like, looking at the slides, it's, of course, there, but... Because there's just, like, no wall whatsoever in the inside. The thing is, like, looking at the slicer, it's also like there's like overhang on the first like 20 layers or something, and like the overhang in this inner circle like definitely does not work without like proper cooling. So I think that's like most of the issue. I think of building my own Core XY myself, but I'm trying to decide if I want to use steppers or servo motors for toolheads and a ball screw assembly for the Y and X axis. Well, from my experience, if it's the first time you do something like that, keep it simple and do the same thing everyone else is doing. Makes it a lot easier. And it's already quite hard on its own. That's my experience. So I would just go with like standard stuff for the beginning, and then like do the second one with like fancy stuff. Yeah. I mean, like, this is kind of like printing somewhat okay now. Like, it will poop out a Voron cube. It will not be pretty. Lack of cooling is definitely like still a big one. I also don't trust the extrusion being super consistent, to be honest. But yeah, like, it's printing. So it was like the minimum goal I set out when I started the project. Something prints. So hey, it prints. And better than last time. So there's definitely some improvement. Like, compared to the last time benchy, mini benchy, like, we're already... Oh, okay. I'm trying to show it next to it, but it was quite horrible. Oh, wait, I'm still in manual focus. Let me go back to autofocus. So that's the bench we printed last time. It was quite like a really bad surface everywhere. So compared to this, we are already way better. It's not perfect, but better. I've built standard 3D printer, but I've never tackled the Core XY. But do you mean like build, like just build something someone designed, or do you want to design it yourself? Okay, but to be honest, like, I feel like there's not a lot we can do today with the Hotend, because I have the feeling that most of the issues we still have are like related to the Hotend in some form. So what I would do is I would just order a new Hotend and fans. Like, I'll search again tomorrow for the fans, and I hope I just put them some weird place where I forgot that I put them. Because if I don't find them tomorrow, I'm fairly certain I trashed the fans, which would be stupid. I'm using a very cheap Ender 3 Hotend clone, so it's really bad. It's really bad. This project started out as like super ultra low cost printer, so I bought like a lot of super cheap components. Everything is replaced with proper stuff by now. The only exception is the fans that are like super stupid and the hot end. Everything else is like nice-ish components. Yeah. So I think I'll just have to bite the bullet and like buy a proper hot end. Like the things I also didn't want to spend a lot of money yet on the printer because I'm not sure if like a nice machine comes out of that. So I don't want to like spend too much money on components. On the other hand, like if I buy something like a Hotend now, it will end up in some printer eventually. So yeah. Okay, yeah, but then what I would do, I would just wrap up the stream now. I will let it finish. I think it takes like another like 40-ish minutes to complete. Yeah, 35 minutes. Estimate is 40, yeah. I would just let it complete, and later I would just post a picture of the completed Voron cube-ish object that comes out. Yeah, I said like tomorrow I will search for fans again. I really hope I find them. Like this would be like I would be really mad at myself because I had like this pile of like packaging material here on the table, and I fear that those fans kind of like snuck their way into this like pile of trash basically, and I just took the entire pile and put it in the garbage. And I really fear that the fans were in there, which would be ah, super annoying. So yeah, tomorrow I look for fans. I will order a hot end. Not yet sure if I will order a Revo hot end or if I will order some temporary stopgap solution hot end. One of the two will happen. Because I think even like a cheap V6 clone will be better than that and will solve like a lot of problems. And then next week, there are two options. Like either we work on this machine. I also have a problem with the switch wire. I had random build failures on the switch wire with stepper Y under voltage. And after some research, it's either the main board having bad steppers, or it's just lack of power. That like there's not enough power. The power supply is not strong enough. We added quite a fair bit of hardware to the printer, and I'm still using the original Ender 3 power supply, which is a good power supply. It's meanwhile, but it's just like most likely not up to the task anymore, like powering everything. So what I did is I ordered now a new mainboard, Manta M4P, and this M4P has a special thing where basically you can have a second power supply that only supplies the steppers. So I ordered the mainboard and I ordered a 24-watt power supply with 100 watts, which we can use to power the steppers independently from the rest of the system. So that's something we need to install. Might be next week. If the stuff's already here, then next week. Otherwise, the week after. And otherwise, we work on this machine. I also have some work queued up for the V0. The V0 gets a canvas tool head. And I also have since months this lightweight X-axis laying around that I want to add. So that would be like the other option because like for the V0 I also have all the parts now. Oh God, I know why the circle isn't working. Remember how I said I never see it make the circle movement? G2 and G3 are the arc moves. So Orca Slicer is configured to generate arc moves. And this machine is not configured to support arc moves. So it just doesn't print the inner wall. That's why the inner wall is missing. Okay, well, that explains a lot. Cool. Wait, let's quickly do that before I forget that. Yeah, because like I never see the printer do the circle. Like G-code arcs. Yeah. So we just need this G-code arcs. Yeah, just put it on bottom. Okay, save. Now it's in. Next time it can support the arcs. Yeah, the arc moves are great actually because like if you don't have arc moves, like the slicer will generate like a lot of like straight moves and it makes the G-code files really big. So basically one circle movement is like, I don't know, like 40, 50 individual line moves. I know how to turn off arc moves in Orca, but haven't seen how to turn on G-code arcs. I'm sure that I understand the sensibility tech. But yeah, basically G-code arcs and arc moves are the same. Like the G-code command basically is just the arc command. I think G2 is clockwise and G3 is counterclockwise, something like that. And yeah, it just saves like a lot of G-code moves. It doesn't necessarily make the print quality better because the STL file basically doesn't support arcs either, right? So the STL files have only triangles. So the circle basically in, like if you have something in Fusion, it's a perfect circle. But the moment you export it to STL, the circle will be converted into like individual line segments. And then what Orca actually does is like it looks at the line segment and says like, oh, that looks like a circle. Let me add a circle there. So it's a bit of like a hack job. I'm actually not quite sure because Orca also supports step files by now. And step files have proper circles. But in the beginning, it was basically what Orca did, but it took the step file, it converted the step file into STL, and then handled the STL. So also there, the arcs were lost. What if you slice a step file? Yeah, that's what it, yeah, just explained. So basically the step file, like if Orca would have perfect support for step files, it would be a circle, but I'm not quite sure if that works like that. But the step file at least has information that this is a circle. For Octoprint, there's also the arc welder plugin that does exactly the same. Like it looks at the G-code moves, and if like consecutive moves follow a circle trajectory, it welds the segments together to arc. That's, yeah, the arc welder. Okay, cool. But yeah, then mystery solved. Like if there's no circle move, then no circles will be printed. So it just skips the commands, and that will most likely do a lot to explain why there are no arcs. Okay, cool. I'll still finish this. So we solved 2.5 problems today. Like the Z's steps were completely off. We fixed arcs. We kind of fixed retraction. Like it's better than before, but I'm not convinced yet. But yeah, then that's it for today. Thanks everyone for tuning in and checking in on the build. And see you next week with Switchwire or this one. Until then, enjoy your weekend and yeah, see you next week. Bye.